On a cold January night in 1803, a crowd gathered in a lecture hall at the University of Glasgow to witness something that defied nature itself. In the centre of the room lay the recently executed body of Matthew Clydesdale, a convicted murderer whose corpse had been delivered directly from the gallows. Standing over the body was Giovanni Aldini, nephew of the famous Luigi Galvani, holding a crude electrical apparatus. What happened next would shock the audience so profoundly that several people fainted, one man died of fright, and the entire room erupted in screams. When Aldini applied electrical current to the corpse's face, the dead man's jaw began to quiver. His left eye opened wide. As the current increased, Clydesdale's back arched violently off the table, his limbs thrashed, his fingers clenched into fists. For several terrifying moments, it appeared that the dead murderer was coming back to life, that science had discovered the secret of resurrection itself. This wasn't an isolated incident of macabre showmanship. For over 2 centuries, scientists have been obsessed with the boundary between life and death, conducting experiments that push ethical boundaries and challenge our understanding of what death actually means. From crude electrical resurrection attempts in the 1800s to modern experiments that have successfully revived dead pig brains, humanity has never stopped asking the question, can we bring the dead back to life? And perhaps more importantly, should we? The modern resurrection experiments began not with humans but with frogs. In the 1780s, Italian physician Luigi Galvani made a discovery that would revolutionize science and spawn a century of attempts to resurrect the dead. While dissecting a frog, Galvani noticed that when he touched the exposed nerves with a metal scalpel during a lightning storm, the dead frog's legs kicked as if alive. Galvani conducted systematic experiments, eventually demonstrating that applying electricity to dead animal tissue could produce lifelike movements. He theorized that electricity was the fundamental force of life itself, what he called animal electricity, and that this force might be the key to understanding and perhaps controlling life and death. This discovery captured the imagination of both scientists and the public. If electricity could make dead muscles move, couldn't it potentially restart a stopped heart? Couldn't it reanimate a recently deceased person? The line between death and life suddenly seemed more permeable than anyone had imagined. Galvani's nephew, Giovanni Aldini, took these experiments to their logical and disturbing conclusion, applying electricity to human corpses to see if they could be brought back to life. Aldini became a travelling demonstrator of galvanism, touring Europe with spectacular public displays of electrical reanimation. Aldini's demonstrations were part scientific experiment, part theatrical horror show. He obtained bodies of recently executed criminals, a readily available supply in the early 1800s, and used them for public experiments that drew massive crowds. The Glasgow demonstration with Matthew Clydesdale was perhaps his most dramatic. Contemporary accounts describe the scene in vivid detail. When electrodes were applied to Clydesdale's face, witnesses reported that the jaw began to quiver, the adjoining muscles were horribly contorted, and the left eye actually opened. When the current was applied to the chest and one arm, the right hand was raised and the fingers moved as if the corpse was pointing. One witness wrote, "Vitality might have been restored if many ulterior circumstances had not rendered this inappropriate." In other words, they believed they could have actually brought the dead man back to life if they had chosen to continue the experiment. A claim that was almost certainly false, but one that terrified and fascinated the audience. Similar demonstrations occurred across Europe. In London, Aldini worked with the body of George Foster, another executed murderer. The electrical stimulation was so effective at producing lifelike movements that the presiding surgeon reportedly said afterwards that he believed Foster could have been fully revived if the experiment had continued. These public spectacles served multiple purposes beyond scientific inquiry. They were entertainment, competing with theatre and other public attractions. They were cautionary displays, using the bodies of criminals to warn the public about the consequences of crime. And they were demonstrations of humanity's growing power over nature, the promise that science might one day conquer death itself. But they were also deeply unethical by any modern standard. The executed criminals had not consented to being used for experimentation. Their bodies were treated as public spectacles and scientific curiosities rather than human remains deserving respect. And the experiments themselves bordered on torture, even if the subjects were already dead. The spectacle of making corpses appear to come back to life troubled many observers. These galvanism experiments had a profound cultural impact that extended far beyond science. In 1816, a young woman named Mary Shelley heard discussions about Galvani's work. and Aldini's demonstrations. That same year, during a ghost story competition with friends including Lord Byron, she conceived of a novel that would become one of the most enduring cautionary tales in literature, Frankenstein, or the modern Prometheus. Shelley's novel was directly inspired by the resurrection experiments. Victor Frankenstein's animation of his creature through electricity mirrors Aldini's work, but Shelley transformed the scientific achievement into a horror story, asking uncomfortable questions. What are the ethical implications of creating or resurrecting life? What responsibilities do we have to the beings we create? What happens when scientific ambition overrides moral consideration? Frankenstein resonated because it articulated fears that many people felt about the resurrection experiments. There was something fundamentally transgressive about attempting to reverse death, something that violated natural and perhaps divine order. Shelley's novel suggested that such violations would inevitably lead to catastrophe, a warning that has echoed through 2 centuries of scientific advancement. The galvanism demonstrations eventually faded as scientists came to understand that electricity could stimulate dead tissue, but couldn't actually restore life. Death, they learned, was more complex than simply an absence of electrical activity. Nevertheless, the dream of reversing death persisted, taking new forms as medical knowledge advanced. In the early 20th century, Russian scientist Sergei Bryukhanenko developed a primitive heart-lung machine he called the autojector. In 1928, he used this device to keep a dog's severed head alive, or something resembling alive, for several hours. The head could see, hear, and respond to stimuli, even though completely separated from its body. Film footage of these experiments still exists, showing the disembodied head reacting to sounds and light, licking its lips, and swallowing food placed in its mouth. Bryukhanenko claimed his work demonstrated that death could be reversed if oxygenated blood was restored to the brain quickly enough. He envisioned a future where people who had died could be brought back to life through mechanical circulation. While his experiments were scientifically interesting, they demonstrated that consciousness could persist as long as the brain received oxygen. They also raised profound ethical questions about what constitutes life and whether existence as a severed head constituted a fate worse than death. In 1947, Soviet scientists took these experiments further. They attempted to revive a dead dog by draining its blood, waiting for clinical death to occur, then refilling the body with fresh blood and shocking the heart back into rhythm. Remarkably, several dogs were successfully resurrected after being clinically dead for up to 10 minutes. They recovered fully, living normal lifespans afterward. This work contributed to the development of modern resuscitation techniques. Today's CPR, defibrillation, and emergency medicine protocols are all descendants of these early resurrection experiments. We now routinely bring people back from clinical death, what would have been irreversible death just decades ago. Contemporary resurrection research has become more sophisticated and in some ways more disturbing than anything Aldini could have imagined. The definition of death itself has become murky as our ability to maintain or restore biological functions improves. In 2019, researchers at Yale University announced they had partially revived cellular function in pig brains 4 hours after the animals had been slaughtered. Using a system called BrainX, essentially an advanced version of Bryukhanenko's autojector, they pumped a special preservative solution through the pig's brain vasculature. Individual cells began functioning again. Cellular metabolism resumed. The brains consumed oxygen and glucose. Under a microscope, neurons appeared healthy and even showed electrical activity. The researchers were careful to state that the brains showed no signs of consciousness or awareness, no organized electrical patterns that would indicate thought or sensation. But the fact that dead brains could be brought back to a state of cellular activity raised unsettling questions. What exactly had they restored? At what point might consciousness return? And what would it mean for an isolated brain to become aware, trapped in darkness without sensory input or any possibility of interaction with the world? The ethical implications were so concerning that the researchers deliberately suppressed any possibility of consciousness returning. They added chemicals to the perfusion solution that would block organized neural activity, ensuring the brains remained in a kind of cellular twilight, alive at the microscopic level, but without awareness. This work suggests that the boundary between life and death is far less clear than we once thought. Brain cells can survive and potentially be revived long after what we consider clinical death. With the right intervention, organs that we thought were irreversibly damaged might be restored to function. Death, it turns out, is more of a process than an event, a spectrum, rather than a binary state. The dream of reversing death has spawned an entire industry, cryonics. Organizations like Alcor Life Extension Foundation and the Cryonics Institute offer to preserve bodies, or just heads, at extremely low temperatures immediately after legal death, with the hope that future technology will be able to revive and cure them. Currently, over 500 people have been cryopreserved, and several thousand more have made arrangements to be preserved upon their deaths. These individuals, or their remains, exist in a state between life and death, frozen in liquid nitrogen at -196 degrees Celsius, waiting for a resurrection technology that may never come. The scientific feasibility of cryonics remains highly controversial. Freezing does extensive damage to cells and tissues, ice crystals rupture cell membranes, blood vessels burst, and the process of thawing causes additional trauma. Current cryopreservation techniques, even using advanced vitrification methods that minimize ice crystal formation, cause damage that we currently have no way to repair. Nevertheless, cryonics advocates argue that future nanotechnology or other advanced techniques might be able to repair freeze damage at the cellular level, reconstruct damaged neural connections, and restore the preserved person to life. They point to the pig brain experiments and similar research as proof that death is more reversible than we once thought. Critics counter that cryonics is based more on hope than science, that it preys on people's fear of death, and that the likelihood of successful revival is vanishingly small. Moreover, even if revival becomes technically possible, what would it mean to wake up centuries in the future, in a world where everyone you knew is dead, where your knowledge and skills are obsolete, and where you have no social or economic place? The advancing possibility of resurrection, whether through improved resuscitation, organ preservation, cryonics, or future technologies, forces us to confront profound ethical questions. First, there's the question of consent. Should we resurrect someone who wanted to die? What about people who were religious believers expecting an afterlife? Do we have the right to pull someone back from death against their wishes or expectations? Second, there's the question of quality of life. Being alive, in a technical sense, isn't the same as having meaningful existence. The pig brains that Yale researchers reactivated were alive at a cellular level, but would have experienced a nightmarish existence if consciousness had returned, aware but trapped in darkness, without body or senses, unable to die. Some revived patients suffer severe brain damage, existing in persistent vegetative states. Is resurrection a gift or a curse in such cases? Third, there's the question of resource allocation. Resurrection technologies are expensive. If we can bring people back from death, who gets access? Only the wealthy who can afford cryopreservation? Only those in developed countries with advanced medical systems? How do we make these decisions fairly? Fourth, there's the social impact. If death becomes reversible, how does that change society? Does life lose meaning if death is no longer final? What happens to inheritance, family structures, and social renewal when people can live indefinitely? These aren't hypothetical questions. Advances in medicine have already doubled human lifespans in developed countries, and we're still grappling with the social implications. Perhaps the most important insight from 2 centuries of resurrection experiments is that death is not the clear boundary we once imagined. Clinical death, the cessation of heartbeat and breathing, is now routinely reversible. Biological death, when cells begin dying from lack of oxygen, can sometimes be delayed or partially reversed. Only information-theoretic death, the complete destruction of the brain patterns that encode personality and memory, seems truly irreversible with current technology. This understanding has transformed medicine. We've moved from accepting death as inevitable once the heart stops, to aggressively attempting resuscitation, to considering organ donation from brain-dead patients, to potentially preserving organs for hours after death. Each advance has saved lives, but also created new ethical dilemmas. The experiments that began with Galvani's frog legs and Aldini's theatrical reanimations have given us CPR, defibrillation, organ transplantation, and advanced life support. They've pushed back the boundary of death, giving people second chances who would have been lost in earlier eras. But they've also forced us to confront uncomfortable questions about what life means, what death means, and whether existence should continue under all circumstances. As neuroscience, biotechnology, and artificial intelligence continue advancing, the possibility of resurrection becomes more concrete. We might develop technologies that can repair extensive tissue damage, restore neural connections, or even upload consciousness to computers. The line between life and death, already blurred, may disappear entirely, but with these capabilities will come choices. Just because we can resurrect the dead doesn't mean we should. Just because we can extend life indefinitely doesn't mean we must. The resurrection experiments, from Aldini's shocking corpses to Yale's reactivated pig brains, remind us that the ability to reverse death carries profound responsibilities. Mary Shelley was right to frame resurrection as a cautionary tale. Victor Frankenstein's tragedy wasn't that he succeeded in creating life, but that he did so without considering the consequences, without taking responsibility for what he'd created, without asking whether he should do what he could do. As we stand on the threshold of unprecedented power over life and death, her warning remains relevant. The scientists obsessed with resurrection have given us incredible tools and insights, but they've also shown us that some boundaries exist for good reasons, that death serves important functions in life's cycle, and that the pursuit of immortality might not lead where we expect. The resurrection experiments continue, now in laboratories around the world, funded by millions of dollars and driven by the same obsession that motivated Galvani and Aldini, the dream of conquering death. We've learned that death is reversible, sometimes. We've learned that it's more complicated than we imagined. And we've learned that with each step toward resurrection, we must carefully consider not just whether we can bring the dead back to life, but whether we should, and what kind of life we're offering them. The dead murderers that Aldini shocked into apparent animation couldn't speak for themselves, couldn't say whether they wanted to return. The cryopreserved patients waiting in liquid nitrogen can't tell us if they still want to be revived if the world they wake to is unrecognizable. The severed dog's head in Bryukhanenko's experiment couldn't express whether existence without a body was worth maintaining. These silent subjects of resurrection experiments remind us that the power to restore life carries the responsibility to consider whether life, under any circumstances, is worth living. That might be the darkest lesson of all. That death, for all its finality, might sometimes be preferable to resurrection. If this exploration of humanity's obsession with conquering death left you with questions, or perhaps a healthy appreciation for mortality, please subscribe. We dive into the strange, disturbing, and thought-provoking corners of science and history where ethical boundaries blur and human ambition pushes against natural limits. Hit subscribe and turn on notifications for more stories about the experiments, discoveries, and ideas that challenge everything we think we know. Drop a comment sharing your thoughts. If resurrection became possible, would you want to be brought back? Where's the line between life-saving medicine and unnatural prolongation of existence? Thanks for watching, and remember, sometimes the greatest wisdom is knowing when not to push further, when to accept limits, when to let death remain what it has always been. The final boundary that gives life meaning.